All right. So question 1, I put it as QH. I'm sure. QH is 150 joules. Efficiency is 35%, which is 0.35. And that's the formula. Work divided by QH is the efficiency. And you make work the subject, multiply those two, and you get 52.5 joules. Okay, number 2, QL. That's the heat from the freezer. 20, heat rejected, 24. Well, I used eta. Please go ahead and use COP. Don't write that. COP is equal to QL by W, that is. I did it in 2 steps. Did you notice? I first find the work. It's 4 kilojoules. And then it's 20 divided by 4. Because COP... Okay, I changed it to COP now. See, I'm using the formula. COP is equal to QL divided by W. Oh, I have it here. See? So first I find the work and then use that formula. Is that okay? QL is 230 joules. QH is 356, isn't it? Work is just QH minus QL. So 356 minus 230, that is 126 joules. Okay, remember that the temperatures have to be in Kelvin, please. So 100 degrees Celsius is 373, right, Antonio? And TH is 400, which is 673. So efficiency is 1 minus TL divided by TH. So you find 373 by 673 and subtract that from 1, you would get 0.4458, which is 44.58%. What do you think about combustion chamber temperature and all that? What is that? The high temperature. Isn't it? So that will be, and you've got to change it to Kelvin, remember. So that is TH. $1,900 plus 273, 2173 Kelvin, and TL is 430. Again, add 273, change into Kelvin. 703. And now theoretical efficiency. Wait. What is the question asking you to find? Don't simply copy. What is it asking you to find? There's a word before efficiency. So which formula are you going to use? Actual efficiency, not the theoretical. Actual means experimental, the actual one. So can you use this formula? You cannot. You know what I'm trying to show is to show you the difference between the two. You understand? So you actually need not write the theoretical one. That's what I'm saying. You're not asked to find the theoretical. You're asked to find the actual. But I'm trying to show you the difference. So watch. Don't write that part. Theoretical is 1 minus. That's the formula you use, right? For theoretical. And you get like 68%. But this is what you write. The actual efficiency is work over QH, which is, wait a minute. Somebody read that question. Look at that. What does it say? It says 7 times 10 to the 9 calories produces what? Of what? Work. So isn't that the work? Yeah, that's right. Work divided by, what's the heat? What's the heat absorbed? It gave you 7 times 10 to the 9 calories. But that won't work because one is in joules, the other is in calories. What do you have to do? Correct. Change the calories into joules. So first understand and then write. See what I did? I changed the calories into joules, multiplying by 4.186, and I got it as 48%. Now compare. Well, 1 calorie is 4.186 joules. That's why I multiplied that. Do you see that the actual efficiency is considerably smaller than the theoretical? That's what I wanted you to see.
So why we need to change the efficiency?
Okay, number 6, I'm explaining work done is pressure times change in volume. Since volume is constant, dV is 0. And if dV is 0, work done is 0. Everything explained. Power. What is power? Work by time. And how are you going to work this out? Because it talks about that much fuel producing 1.4 times 10 to the 10 joules of work in 1 hour. So you know the work in 1 hour. And power is just work in 1 second, isn't it? Okay, I said refer to question number 5 because it's the same thing. And power output is work done in joules divided by time in seconds. Okay, the work is given as 1.4 times 10 to the 10. And why did I divide by 3600? Because 1 hour is 3600 seconds. Okay, and then there's a small mistake in the answers because they want it in horsepower. Have you heard of horsepower? 1 horsepower is 746 watts. That'll be given to you. So you have to divide this by 746 to give you 5200 horsepower, which is 5.2 kilo horsepower. And so you got to change the units of all the answers into kilo HP. Did you do that? Kilo HP. I put it as HP again. I forgot to put K. Did you notice? Yeah, kilo HP. So change the unit to kilo HP. Okay, change in entropy is dQ by T. dQ is how much heat you take out, right? Or given. Here the change in entropy is given, and you're asked to find how much work does it do. Are you listening? Or simply writing? dQ is TdS, that's mathematical. Isn't the temperature 273 Kelvin? Times they gave the change in entropy as 3.7, right? So I got that number, 1010 joule. But what are they asking you to find? What are they asking you to find? And what did I find? The heat. Yeah, don't worry about dQ, delta Q is the same as Q, okay? So now how do I find the work? What kind of change is it? Isothermal. What do you know about an isothermal? Constant temperature, therefore, I'm going to prove it. dQ is du plus dW. Isn't that the first law? Instead of delta, I'm writing d, okay? Because I'm used to writing for. Look, calculus based, I write du, but for you I have to write delta u. Will you forgive me for that? If I write d, it stands for delta. Come on. Delta. But most of the time I write this so I forget. For you, it's delta means change. It's the same thing. For isothermal, du is 0. Is du 0 for isothermal? If du is 0, what do you get? If du is 0, what do you get? When you get dQ is dW? Yeah, finished. So, actually dQ is dW. That's 1010 joule. Again, dQ is du plus dW for isothermal. I have to do all the writing again. du is 0, so dQ is dW. Since heat is removed, dQ is negative 5 joules. Therefore, dW is also negative 5 joules. ds is dQ by T. And dq is m times the latent heat from the last chapter. So that's 0.5 times the latent heat of ice is 3.36 times 10 to the 5. That will be given to you. And 1.68 times 10 to the 5 is dq. And ds is just dq divided by t. This is one of the best questions because it combines two chapters. dq by t is, what you found, divided by 273 because that's the melting point of ice, isn't it? 273 Kelvin, 0 degrees Celsius. Okay. And now you have two chances. Is it positive or negative? Are you adding heat or removing heat? Removing heat. So if you're removing heat to change water into ice, you're removing heat. Therefore, ds is negative because dq is negative. All right. Number 11. Carnot efficiency is the theoretical efficiency. So you use 1 minus TL by TH. 1 minus 310 by 450. And you get 31.1%. Okay. So number 12. You're asked to find the Carnot efficiency. That is the theoretical efficiency. So you only use the temperatures, isn't it? So you go 1 minus TL by TH. Please change it into Kelvin. Don't forget. Can somebody try working this out without changing it? And I'm almost sure you'll get another answer. Try it. This one you get 68%. (13) QH 7,000 joules. QL is 3,000. And efficiency is 1 minus QL by QH. It's 1 minus 3,000 by 7,000. Simply calculate. Yeah, you get 0.5714, which is 57.14%. Okay. All right, 14. If you didn't get it, here it is. 35%. I told you it's always taken as 0.35. And QH is given. How do you know? Because it says receives. It's 150. You have to find QL. So that's the formula for efficiency. That is QL by QH is 1 minus E. So QL is that whole thing times. Before I substituted, I just made it the subject and then substitute. You get 97.5 joules. Yeah, I'm just showing that QH goes to the top and becomes a multiplication. Right? Okay. In 15, E is 0.35. You have to find the temperature of the cold reservoir, that is TL, and TH is given as 500 Kelvin. Okay, now you use 1 minus TL by TH. Make TL the subject carefully. This TL by TH is 1 minus E. TL is TH times 1 minus E. Plug in the numbers. 500 times 1 minus 0.35. 500 times 0.65. It's 325 Kelvin. Yeah. All right, 16. Like I said, isothermal process, change in internal energy 0, therefore change in temperature 0. All right. And 17. QL is 20, QH is 24. All you do is just subtract to find the work done. Because work is QH minus QL. That is 4 kilojoules. Okay. 18. Just watch carefully. how the argument is. Isochoric process means isovolumetric, right? I'm writing everything. That means the volume is constant. Okay. If the volume is constant, dV is 0, therefore the work, which is P dV, is 0. Why did I stop there? What? 19. Work in 1 day, 600 megawatts. That is 600 times 10 to the 6, isn't it? Mega is 10 to the 6. So work, I made that mistake. It's work in 1 second. Work in 1 second. So I change it to work in 1 day. 1 day has 24 times 3600 seconds, isn't it? 1 day has 24 hours. Believe me. And each hour has 3600 seconds. So total seconds. All right. So you have 5.184 times 10 to the 13 joules. Coal used, 4.8 times 10 to the 6 kilogram. And total heat, QH, you multiply that mass with the heat of combustion. And you get 15.84 times 10 to the 13 joules. Then work is QH minus QL, but QL is, because you're asked to find, wait a minute, what are you asked to find here? Heat exhausted. What's the letter for that? Okay, that's what I'm trying to find. QL is QH minus W, so that is this minus there. That's the answer. And of course it's what? P, close to 1.1 times 10 to the 14. Right, number 20. Isochoric means constant volume, isn't it? dV is 0, therefore work is 0, and the first law, change in internal energy is Q minus W, and so delta U is Q. But how did I know it's negative 50? Because the question said it decreases by 50 joules, isn't it? Decreases, negative 50. Q is negative 50 joules. Thank you.